Good morning, afternoon, or evening. How you all doing today? Welcome back to Mr. Morrow's geometry class. Today we are talking about the transitive and substitution properties, two extremely powerful properties for proofs. Just like all the other theorems that we've been learning, we will be using this all year, but this one in particular, it's very, very powerful, and it's quite easy as well. So let's do it. The transitive property. Transitive property, okay, states that if angles or segments are congruent to the same angle or segment, they are congruent to each other. It's easier to see this than to read it. If angles or segments are congruent to the same angle or segment, then they are congruent to each other. Consider the following segments and angles. First are segments, and then we'll see how it works for angles. If you see, we have segment AB, EF, and CD. If I tell you right off the bat, my friends, that AB is congruent to CD, so AB is congruent to CD, but CD is congruent to EF, what do you think I can conclude from here? Yes, sir. And AB is congruent to EF. Very good. And if you noticed, it really helps to label in this particular case, because when I labeled that AB was congruent to CD, I had one tick mark. But then if CD is congruent to EF, well, the tick mark of CD can also count for the tick mark of EF, and therefore they all have one tick mark, so that means that EB is congruent to EF. You saw this a little bit in algebra. You're going to see this time after time after time in geometry. So pretty cool stuff. With an angle, it works the exact same way, gentlemen. If I tell you that angle A is congruent to angle B, but then that angle A is congruent to angle C, what can I conclude? Yes, sir. That's absolutely 100% right. Angle B is congruent to angle C. So that's one part of the transitive property. There are two parts to this bad boy. May I continue? All right, awesome. Thank you, guys. Now, another version of the transitive property theorem states that if angles or segments are congruent to congruent angles and segments, or segments, then they are congruent to each other. So if I tell you that angle 1 is congruent to angle 2, okay? But then I tell you that angle 2 is congruent to angle 3, and then I tell you that angle 3 is congruent to angle 4. What can you tell me? What do you think you can tell me? Yes, sir. Beautiful, man. For real. Great job. Angle 1 is congruent to angle 4. Let me show you how this one works in particular, okay? As you see, you had 4 angles here. Notice how you have the double up on angle 2 and the double up on angle 3. Okay? So the ones that are missing here are the angle 1 and the angle 4. Those are the guys who are going to be congruent. Okay? Yes, sir.
So let's say they always give it like that. You see the double ups, you can always say that.
That's exactly why. That's exactly why I showed you the double ups. Yeah, it's the ones that do not double up that are going to be congruent because of this. If angles or segments are congruent to congruent angles or segments, then they are congruent to each other. So since angle 1 equals angle 2, 2 is congruent to 3, 3 is congruent to 4, then 1 has to be congruent to 4. Yes, sir. That's exactly right. This is a kind of a chain of reasoning. The reason why we even spoke about the chain rule was because of later properties like the transitive property. Does that make sense, guys? All right. Let's check out how it works in a proof, gentlemen. If I tell you that FG is congruent to KJ, okay, FG is congruent to KJ. And then I tell you that GH is also congruent to KJ, so they all have one tick mark. Okay? I want to prove that KG bisects FH. Well, my given is that FG is congruent to KJ, and GH is congruent to KJ. That's given. But if I know that, what else do I know now using the transitive property? I know that FG is congruent to KJ, and I know that GH is congruent to KJ. What do I know? Yes, sir? Beautiful, son. FG has to be congruent to GH because of the transitive property. If segments are congruent to the same segment, then they are congruent. The same segment here would be KJ. All right? FG was congruent to KJ. GH was congruent to KJ. So that means that FG has to be congruent to GH because of the transitive property. And then, if we know that FG is congruent to GH, it's quite simple now at this point to prove that KG bisects FH. Why? Definition of segment bisector. If you have a segment bisector, that means that it bisects or cuts that segment into two equal halves. Pretty cool, right? Powerful. Powerful, powerful theorem. I see you guys writing, so don't worry. I'll let you get that down. This is a really, really, really good theorem. Transitive property is really good. Yes, sir? You sure? You want me to go through it again? You promise? Okay, does anyone need me to go through it again? You know, I have no qualms with that. Okay, good stuff. May I continue then, gentlemen? Thank you, brothers. Okay, substitution property. It's not really a theorem. It's more of just a property. It stems from algebra, okay? And what it states is when a number value, this is where substitution really comes in. Please be cognizant of this. When a number value is replaced or substituted in an equation or statement dealing with numerical values, you usually use substitution for numerical values. It's almost the same as a transitive property. If I tell you that angle A equals 5 and angle C equals 5, then I can say that A is equal to C. But since I use numbers, okay, that's substitution. So it's very similar to the transitive, but transitive is not using numbers. Substitution will be using numbers, numerical values. Yes, sir. I'm going to show you an example right now on how to use it. Thank you very much, sir. For example, if I tell you that the measure of angle 1 is plus the measure of angle 2 is equal to 90 degrees, and I tell you that the measure of angle 1 equals the measure of angle 3, we're dealing with numbers here. Again, some of you may say, wait, this is just like the transitive property. It is, but with numbers. What can we conclude here? That's exactly correct, my brother. The measure of angle 3 now plus the measure of angle 2 now equals 90 degrees. So again, it's almost identical to the transitive property, okay? Except we're using numbers, numerical values, and equations. So since we know that measure of angle 1 is congruent to the measure of angle 3, I can substitute that original equation of measure of angle 1 plus measure of angle 2 equals 90. I can substitute that measure of angle 1 with the measure of angle 3 due to the substitution property. Okay. Next. Example 3. If I tell you that angle A is congruent to angle B, and I want to find angle A, when I look at angle A and B, I have numerical values here. I have an equation, right? So what can I do? I can literally, go ahead, brother. Phenomenal, son. Angle A, which I can substitute with x plus 10, is congruent to angle B, which I can substitute with 2x minus 4. Now, please try to remember, guys, congruent and equal are almost the same, except equal is used when we're dealing with values, with numerical values. When we're just dealing with angle names or segment names, we're dealing with congruency. When we're dealing with measures of angles or measures of segments, actual numerical values, equations, we're using equal. And now this is just simple algebra. I subtract x to both sides and I add 4 to both sides. So 14 equals x. Please be aware that is not your answer. It depends what they ask you. If I had said to you solve for x, that would be your answer. But I want to find the measure of angle A. So the measure of angle A, now we do another substitution. Angle A is x, which I can substitute with the value of 14 plus 10. So that would equal 24 degrees. That's the measure of angle A. Does that make sense, y'all? Pretty simple, right? Easy stuff. This is kind of like algebra. Well, not kind of. This is algebra, but just using a geometric sense. Did everyone get that one down? Okay. May I continue, brothers? Thank you. Okay. Example 4. I try to give you a lot of examples in this lesson. If angle 1 is complementary to angle 2, think about this, guys, and angle 2 is congruent to angle 3, then angle 1 is complementary to angle 3 by substitution. Okay, I kind of already gave you the answer here. I just wanted you to understand how this works also with complementary angles. Yes, sir? That's exactly correct. Well done, sir. You're on fire, brother. The measure of angle 1 plus the measure of angle 3 has to equal 90 degrees. Phenomenal, son. Because if angle 1 and angle 2 are complementary, that means that their sum is 90. But if I'm telling you that angle 2 is congruent to angle 3, then I can substitute the measure of angle 2 with the measure of angle 3, hence giving me that the measure of angle 1 and the measure of angle 3 are also complementary, or in other words, their sum is 90 degrees. Okay? Now again, I couldn't assume that the angle 1 and angle 2 are 90 because it does not have the little box. I was told that they were complementary, and that's why I know that their sum is 90. Let's do another proof. Example 5. The measure of angle 1, or I kind of messed up there, guys. I should have put, because we're dealing with numerical values, I should have put the measure of angle 1 plus the measure of angle 2. I apologize. Equals 90 degrees. Okay? So I know those two are going to be complementary. And I'm telling you that angle 1 is congruent to angle 3. I want to prove that again, my bad, the measure of angle 3 plus the measure of angle 2 is 90 degrees. So statement 1, of course, as always, is our given. The measure of angle 1 plus the measure of angle 2 equals 90. That's given. Okay? That was weird. Okay. Next. Angle 1 is congruent to angle 3. Given. Awesome. What's my answer? How do I prove that the measure of angle 3 is plus the measure of angle 2 is 90 degrees? Yes, sir. That's exactly correct, my brother. The measure of angle 3 plus the measure of angle 2 has to equal 90 because of substitution. I literally took the fact that since angle 1 is congruent to angle 3, I can substitute or replace angle 1 with angle 3, making the measure of angle 3 plus angle 2 90. Yes, sir. Yes, sir. No. Don't abbreviate sub. Put subtraction or substitution. Thank you. That's a very good point. Because if you just put sub, I don't know if you're saying subtraction property or substitution. So that's a very valid point. Thank you, sir. Yes, sir.
On a quiz, you were given us these givens and you say make the best conclusion with, can you say that with the trisect?
Okay. No. The question was, can I say that, well, first of all, angle 2 is never going to be a trisector. You mean that, let's say I had labeled these rays. Whoa. Okay, wait, let's go back. Okay. You're saying, can you say, if I told you on a quiz, I gave you these givens, and I said to you, okay, what's the best conclusion? What my boy wanted to know is, could this ray and this ray be trisectors? No. When did I say that angle 1 or 2 or 3 are congruent? The answer is never. I never said that. So no, those two rays are not trisectors. If I say what's the best conclusion here, that's the best conclusion. That angle 3 plus angle 2, you could say are complementary, or the measure of angle 2 plus the measure of angle 3 is 90. If you told me at this point that the measure of angle 1 and angle 2 form a right angle, I kind of would not really accept that. That's a little bit too simplistic at this point. Yes, sir. Talk to me, brother. Thank you.
We're using the substitution property, but sure that
No. I know that angle 1 is congruent to angle 3, my brother. But how do I know that angle 2 is congruent to all of those? Angle 1 could be 60, and angle 3 could be 60. Then angle 2 is 30. That's not a trisector. The rays there do not trisect that angle per se. I would have to prove somehow that angle 2 is congruent to angle 3 as well, or that angle 2 is congruent to angle 1 as well. That's a great question. You're thinking. That's what I love. Good job, my brother. Does that make sense for real, though?
Yeah.
Okay. How are we doing here, guys? Good? All right. And I think, no, yeah, there's one more. Okay, awesome. Let's do some math here. They tell you that angle P is congruent to angle R. So angle P is congruent to angle R. And angle Q is congruent to angle R as well. So they all have 3 tick marks. Express the measure of angle Q in terms of X and Y. And express the measure of angle Q in terms of X and Y. Okay, yes, sir. Okay, well, what is it? And wait, hold on. Give me 1 second. I may have made a mistake here. Okay, I thought I had made a mistake here, guys. They're not asking for measure of angle Q in terms of X and Y. They're asking for this in terms of X and A. Sorry, my bad. So, okay, so this changes things just a little bit. So basically, what I want to do is express angle Q, which at this point is congruent to either angle P or angle R because of the transitive property. But I have to replace that Y with an X or an A. So let's look at angle R. If I tell you that 2y plus, that's 2y plus A, right, is equal to X plus Y plus A. Let's solve this for Y. If I want to solve for Y, I'm going to subtract Y to both sides, and I'm going to subtract an A to both sides. So I have Y equals now X, correct? So now I can replace this Y over here with an X. So angle Q will equal 2X plus A. Did that make sense? Did you see why I did that? Did you see why I solved for Y? Because I wanted this in terms of X and A. That was my mistake, not X and Y. My bad. Sir. Okay, why did I subtract the Y and not divide? Because I have a plus Y here. How do I get rid of a positive Y? by subtracting, not dividing. I subtract y over here, 2y minus y is y. I subtracted a to both sides, so y equals x. And then I plugged in that y as x into angle P. Do you understand? You would not divide at all. Does that make sense, brother? What do you mean what I do with the 2? What's 2 y's minus a y, son? 1 y. Yes, sir. Thank you. Okay, we set, hold on, let's do this again. Thank you, guys. I appreciate the honesty. Let's do this again. We want to solve for angle Q here in terms of x, okay, and a. That's what we want to do in terms of x and a. So in angle P, I have an x, a y, and an a. In angle R, I have a 2y and an a. I want to express Q only with x's and a's. So what I did first was I said, well, I know for a fact that 2y plus a equals x plus y plus a. That's a fact, right? But I want to replace the y's with x's and a's. So I'm going to solve for y right off the bat. I'm going to subtract a to both sides, leaving me with 2y equals x plus y. Then I'm going to subtract y to both sides, leaving me with y equals x. Now, I could either plug it into here or here, my brother. It does not really matter. Let's plug it into both, and you'll see that they both give me the same values. If I say that y is equal to x, and I plug it into this one, I have x plus a. So Q would equal 2x plus a. If I plug it into this guy over here, y is x. So 2 times x, I replace by substitution, plus a. Does that make sense, sir? Thank you very much. So here I had to use the transitive property, and then I had to use substitution. Does that make sense, gentlemen? Awesome. Thank you for a great class. Hope you learned a lot, and have a wonderful day.